Okay, so I have a bit of a different video for you guys today. We're going to be looking at a bit of MATHHAMMER so we can understand save stacking in a bit more detail. I think most people have sort of an intuitive understanding of save stacking, just that they've experienced it in the game and they know that it's pretty powerful, but they won't have a sort of technical knowledge of exactly what is happening and exactly why it's so powerful. So I just want to go through that with a few examples so that people have sort of a clearer picture of what is happening and what makes save stacking so powerful. If you like this sort of video, let me know, because there's a few other topics I want to do sort of math heavy videos on, and I'm curious to see how much interest there is in them. So we're going to get straight into it. We're going to use MS Paint for the examples, and I've made myself nice and small so I won't be taking up the screen, and yeah, let's just get straight into it. So first off, we're going to look at two units that are both taking a bunch of attacks, and we can give one of them all that defense, and we've got to figure out which unit it's best to give all that defense to. So let's imagine we're taking 36 attacks, and we've got a unit with a 5-up save and a unit with a 3-up save. All right, so both these units are taking 36 attacks. They're red 0 and they're damage 1. And we've got the option to do all that defense on one of these units, but not both of them. Which unit should we use the command on? So first things first, we should figure out how much damage we're taking before we use the all out defense. On a 5-up save with 36 attacks, we're going to save 12. We're going to make 12 armor saves, and then we're going to fail 24 of them. On the 3+ save, it's going to be inverted. We're going to make 24, and then we're going to fail 12 of them. All right, so that's the base case. Pretty standard so far. If we give them +1, this 5-up goes to a 4-up. So it'll be 18 successful saves out of the 36, and then also 18 unsuccessful saves out of the 36. On the 3-up, if we add +1 there, it goes to a 2-up, and we get 30 successful and 6 unsuccessful. All right, so far should be pretty straightforward. And if we look at the difference that our +1 made over here on the 5-up save, we can see we went from 12 to 18. That's an improvement of 6 additional saves. And over here, we went from 24 to 30. That's also 6 additional saves. So the first thing you'll notice is that this seems to contradict the idea that save stacking even exists. All right, we've made 6 successful armor saves, 6 additional successful armor saves by using all that defense on either unit, right? So that might lead you to think, well, it doesn't even matter. There's no such thing as save stacking. +1 to your save is just +1 to your save is just +1 to your save. Like, it doesn't matter. But there's another way to look at the difference. If we look at this right-hand column, this is how many wounds we've taken. And if we consider that 18 is 3/4 of 24, so we reduced the amount of wounds that we're taking by a quarter, right? Whereas on this side, on the 3+ save, we were taking 12 wounds, but now we've gone down to 6. That's a reduction of half, right? 6 is half of 12, whereas 18 is 3/4 of 24. So on the 5-up save unit, we reduced our damage by a quarter. On the 3-up save unit, we reduced our damage by a half. And I think that's the thing that's confusing for a lot of people when they start thinking about the math on this issue. They notice both of these things at the same time and they seem contradictory. How can it be that it's a flat, absolute 6 saved either way? Obviously 6 is coming from 1 in 6. We improved our odds by 1 in 6 with +1 to the save, and so we're saving 1/6 of the attacks because of it. But at the same time, it's also a percentage change. It's a quarter or a half, and it's different for the 5+ or the 3+. So there's sort of two ways to see it, and I'd argue that this side on the right is the correct way to look at armor saves. All right, you've had the experience of save stacking being powerful, and it's powerful because of this. So to demonstrate exactly what is happening, exactly why this side is the correct one, I'm going to deal a few more wounds to these units. So let's assume we didn't have to choose this turn. Let's assume we used our +1 to our save on both units this turn, right? We used leadership of the alpha or something, and we got +1 to save on both. So next turn, let's say we deal another 9 attacks to each, and also I guess it's relevant, we should figure out how many wounds we have in these units. So this 5+ save unit, let's say it had 24 to begin with, and this 3+ save unit, let's say it had 12 to begin with, right? So after the attacks, we would have lost them all in both units, but because we did an all-out defense, we've actually saved 6 from each unit. So the new unit size is 6 for both of them, okay? And it's purely because we saved 6 with our all-out defense. All right, so what's the base case now? All right, we don't have to worry about all-out defense. Just how many wounds do we take? We're taking another 9 on each unit. So we make 9 saves, and out of 9, we're going to save 3 on the unit with the 5+ save, and then we're going to fail 6, right? And that's going to be enough to kill the unit. On the unit with the 3+ save, we're going to have the inverse. We're going to make 6 saves, and we're only going to fail 3, right? So at the end of the day, we have, let's pick a color, like green. We have 0 dudes left in our 5+ save unit, but we have 3 left in our 3+ save unit. And this difference, this is why save stacking is powerful. This is actually the mechanics of what is happening with save stacking. To put it another way, like another way to think about what's going on here, is that each time you save a wound, essentially, you get to have another armor save in the future to protect that same wound. So like you get another go in the future. And if you've improved that save, then there's a good chance that the save in the future will also be improved as well. So when we save 6 over here on the 5+, we're saving 6 wounds that have 5+ saves, whereas over here on the 3+ side, we're saving 6 wounds that have 3+ saves. So we're protecting better armor saves by improving our already good armor save. I guess another way to think about this is in terms of healing. You could imagine if we're healing a unit or adding models to a unit that has a high armor save, it's going to be harder for our opponent to then take those wounds off them again compared to if we healed a unit that had a worse armor save. And that's essentially the same thing. This amounts to healing 6 wounds back to this unit, and it's just higher value to protect high value wounds than it is to protect low value wounds. So that's why save stacking sort of works in general. That's the mechanic of it. But I understand none of this tells us anything sort of useful about the scale of save stacking, about how effective it is. So I'm going to reset this board and we're going to look at a way to calculate how effective save stacking is. And I'll give you sort of a cheat sheet at the end because this involves a tiny bit of math, but actually there's a really, really quick, easy way to do it as well. So I'm just going to reset this board. I think chuck this on it. All right. So what we're going to look at is something called effective wounds. And effective wounds is essentially how many wounds you need to cause to a unit to expect to destroy it, right? How many armor saves you need to force that unit to take before the balance of probability suggests that it should be destroyed. And the way we're going to work that out is by taking the wounds of the unit and then sort of dividing that by the chance that you fail an armor save, right? So the chance of failure is what I'm going to call that. And if you think about what we're doing here, when you learned division, you probably learned it like this. Your teacher would have said, like, let's say we're doing 6 divided by 2, and they would have said, what we're really asking here is how many 2s are there in 6, right? This divided by is really a how many question. So it's 6, how many 2s, right? So 3, there are 3 2s, that's a horrible 3. 3 2s in 6, all right? So the same thing is happening here. If we take, say, a unit of 10 Chaos Warriors, they have 20 wounds, and the chance of failure on Chaos Warriors is 1 in 3 because they have a 3-up save. So the question we're answering with this is 20 wounds, how many 1 in 3 chances do we need to throw at those wounds before they run out, right? How many armor saves do we need to force this pool of wounds to take before it's probably going to be exhausted? And again, I'm going to show you the technical math thing that's happening here, the way to work it out yourself if you want to, but I'm not expecting you to do this in a game. It turns out these things are actually very, very easy to work out in your head. You just need a cheat sheet that I'll provide after. So the way that you want to work this out is you do something called stay, change, flip, because we're dividing a sort of a fraction by a fraction, which is the 20 stays. You change the divides into a multiply, and you flip the 1/3 to 3/1. 3/1 is just 3, so it's really just 20 times 3, right? And 20 times 3 is the easy thing. You just have to remember that a 3-up save is times 3. So 20 times 3 is 60. So our effective wounds for a unit of 10 Chaos Warriors is 60. In other words, if you wanted to destroy a unit of Chaos Warriors with Ren nil 1 damage attacks, you would have to force that unit of Chaos Warriors to take 60 armor saves, right? And that's actually a lot of saves, but that's also why we use Rend and 2 damage attacks and all sorts of other stuff, right? Like mortal wounds and that sort of stuff. But just to have a look at what save stacking does to our effective wounds, what happens if we change this to a 2-up save? So let's consider we still have 20 wounds in the unit, but now we divide it by 1 in 6, right? Because we have 1 chance of failing our 2+ save, right? This is the all-out defense or the Mystic Shield or whatever it is. And same as before, we did the stay, change, flip. Now it's 20 times 6 instead of 20 times 3, and equals 120. All right, so you need to throw 120 armor saves at a unit of Chaos Warriors that has all-out defense in order to kill that unit. And that's double the 3+ save, right? It is so much more damage. And that's because every single time you make one of those successful armor saves, you get to have another go at an armor save. And more than that, the second go that you get at doing the armor save is also improved because it also gets the +1. That's why it's so effective. If you compare that to like hit rolls or wound rolls, it works kind of differently. With a hit roll, if you make a successful hit, you don't then get to make another attack. But with armor saves, you basically do get to make another armor save at some point in the future. So I just want to show one last thing before I give you this cheat sheet. What happens if we add a ward on top of this, right? How does a ward affect our effective wounds? And I'm going to use a 5-up ward. I'm just going to use a 5-up ward because it's easier for the math than a 6-up ward. The 6 is actually the only one that's hard to do in your head, but it doesn't really matter because the 6-up ward isn't very good. So I'm going to do a 5-up ward, even though it's hard to get Chaos Warriors a 5-up ward. So what we're going to do is we take this value and we just start with that, right? So 120 over the chance that you fail the ward. So a 5-up ward is 2 out of 3. And if you do the stay, change, flip, it's 120 times 3, which is 360, and 360 divided by 2. So that equals 180, right? So you multiply all these things together. The better your armor save, if you have a ward as well, it's going to be a massive increase to your effective wounds. Having a good ward and a bad armor save is not very useful. Having a good armor save with a really, really bad ward kind of sucks. But if you can stack them together, then you start getting really obscene numbers. Throwing 180 wounds at a unit, making them take 180 armor saves, is an obscene amount of armor saves to be taking, right? Like when I go to, when I play games of Warhammer, I have a little cube of dice, and that's 36 dice. And I bust that out when I'm doing a ton of attacks at once, right? And that's just a ton of attacks, right? I might throw 40 attacks, I'm going to hit with 30 of them, wound with 20 of them, and my opponent takes 20 armor saves, and that's in like a good situation. So this 180, even if you have 2 damage attacks and you need to throw 90 of them, this is still an absurdly high number. So once you start getting into this 2+ save territory, units become damn near unkillable. And it's really important to notice that the difference between a 3+ and a 2+ is much, much bigger than the differences in the other saves. So I'll show you that in a second, but I just want to give you the cheat sheet so you don't have to be doing this math. You can just sort of figure it out quite quickly. So we'll erase some of this. Let's see how far back our undo does. Yeah, that'll do. So I'm going to do the save on the left. So we'll do, there's a 2+, a 3+, 4+, 5+, and 6+. And then we're considering what this does to our wounds. So it'll be wounds times something. And for a 2+ save, it's just wounds times 6. For the 3+ save, it's wounds times 3. For the 4+ save, it's wounds times 2. This is just, if you think about it, right, you block half the damage, so you need to take twice as much damage. For the 5+ save, it's wounds times 1.5. So you can imagine if you have like 40 wounds in a unit that has a 5+ save, you'll have to deal 60 damage to it, because that's, you're just halving the number and then adding that on top of it. If you've got like 30 wounds, it'll be 45. If you've got 60, it'll be 90, right? You can do that in your head very, very quickly. The 6+ save is the only one that is not easy to do in your head, just coincidentally, and that is wounds times 1.16. And this is like, if you have 10 wounds in a unit with a 6+ ward, you will need to deal 12 wounds to that unit to kill it. But most of the time, it's hard to do that math for that one in your head. So that's the cheat sheet. That's the easy way to remember it. And it really is not that difficult to remember these 4 numbers. Once you get used to them, it's fairly straightforward. They're sort of intuitive as well. You have a 1 in 6 chance of failing here. You've got a 1 in 3 chance of failing. These ones are easy to remember for that. You block half your wounds, so you take twice as much. That's easy to remember there. The 5+1 you get used to pretty quickly. It just increases by 50% of what you've got. This one's really important to remember because a lot of the good wards are a 5+ ward. So you're trying to work out like how much damage am I going to do to this Nurgle thing. This thing is an easy way to remember that sort of extra durability. So that's the cheat sheet. I do want to show you just some graphical representation of what is actually happening. So we're going to jump over to Chrome and we're going to have a look at this chart. So this is save value versus effective wounds. You've got your save value along the bottom, and you've got what it does to the value of 1 wound. So obviously 1 wound with no armor save is worth 1 wound. But if you get a 6+ save, then it's worth 1.16 wounds. All right, just following that cheat sheet from before. And then it goes up to 1.5 wounds up here. It goes up to 2 wounds if you got a 4+ save. And it'll go up to 3 wounds if you got a 3+ save. And then it goes up to 6 wounds if you got a 2+ save. And obviously the jump between the 3 and the 2 going all the way up here is such a big jump compared to, say, going from 5 to 4, which only goes up this much. right? This is effectively how much more durable your unit gets. So the space between this 3 and 2 is still only +1, but the amount of extra durability you get is absolutely insane. And you have to think about this in terms of having a ward as well. Obviously, it's better to use wards on units that already have a lot of durability, because this save stacking sort of thing multiplies by itself. All right, so I think that's most of it. I do want to show people just one simulation. We've got Age of Simulator. It's a tool I recommend if you're into the sort of mathier dice math tools. There are some that are like, you just plug in 1, 2, and 3, like hit, wound, save, and it gives you like a really quick number. But this one is for a more detailed analysis. So if you're interested in really mathing something out, I recommend ageofsimulator.com. And if we wanted to look at that unit of Chaos Warriors, which, if we remember, had, with a 2-up save, it had 120 effective wounds. How many attacks would we need to put into that unit? So if we assume we have, like, I don't know, one attack models, just how many attacks are we going to have to put into that unit? Well, it's going to be 240 wounds, and it's going to be double that again if we're hitting and wounding on 4s. And this is just for instance, just to show you sort of the power of it. So we've got a 2-up save, we're hitting and wounding on 4s, and we're throwing 140 dice. Sorry, 480 dice. I'm not sure why I said 140. 480 dice. Imagine rolling 480 dice and then picking up all the 4s and then rolling them all again. And at the end of all this, you should get about a 50% chance to do 20 or more wounds, right? To do about 20 wounds. So we'll hit simulate. We'll see if I've done my math correctly, if I'm, telling you the truth about how effective save stacking is. And you can see a chance of doing at least 20 wounds is about 50%, right? That makes perfect sense given all the previous math. You should have an expected sort of effective wounds of 120, which means with all the hits and all the wound rolls that you're going to have to do, or I guess all the misses and all the failures to wound, you're going to have to throw 480 attacks at a unit of, this is just 10 Chaos Warriors who are giving themselves +1 to their save with all that defense. So there are situations in Age of Sigmar where the math skews so far that you are basically doing 0 damage per attack, and you may as well not bother with those sorts of attacks. There are a lot of situations where people think, oh, I'm in combat anyway, I may as well see what I do. But often you'll be in a situation, perhaps without realizing it, where you are doing so little damage and where you are taking a fair amount of damage back. And just knowing just how futile your attempts will be against something that's save stacked correctly will often lead you to make better decisions about when to retreat, or where you want to engage, or which tools you want to include in your army. Things like Raw or Extra Rend, or ways to stop your opponent's Mystic Shield, because your army will otherwise struggle to deal with targets that have been save stacked. So I think that's it for this video. I've got, I guess, one more graph to show you. This is not hugely important, but this is just a little spreadsheet that I made up that shows the effect of sort of wards with save stacking. So if you have no ward, you can see that's that graph, same as this one. But if you put in just a 5-up ward, it multiplies the effect dramatically. So this 20 wound unit with a 2+ save, let's say, has 120 just like before, goes all the way up to 180 just like I showed you. And the difference in durability from it just having a 3-up save and being effectively about 60 wounds to being effectively 180 wounds is absolutely staggering. So yeah, that's about it for this video. I just wanted to show you what is happening with save stacking, why it's so powerful, and what the mechanics of it are. Like I said, there's a few more videos that I want to make about math-related topics. I think the next one will probably be where to place your buffs efficiently. If you've got like +1 attack or +1 to hit or +1 to wound, which units benefit most from it and how to figure that out. And you know, same thing with debuffing your enemy's units, just making the best use out of those buffs. If you're interested in that sort of thing, let me know, and you can expect that video sometime in the future. So yeah, I'll leave it there and have a good day.